All the vendors around our industry right now have had to deal with this. All the analysis vendors, all of them, all the big names, is now we can't rely on encrypted streams. Now we have to do decryption to properly measure application response time and measure performance. I was just dealing with a customer last week. So it was an encrypted stream, right? Like, so we had an encrypted, it was actually interesting, a lot of what we're talking about. It was like an application that was using UDP and it was encrypted and we didn't have a lot to go on. And I pumped their pcap in a Wireshark and I went, wait a second. I think something that would be better for people to understand is, or spend their time learning, keep UDP simple because it is.
Hey everyone, it's David Bombal back with Chris. Chris, welcome.
It's great to be back, David. How you doing?
Very good. And you?
I'm doing
busy, I believe,
good.
yeah? Is it SharkFest and Defcon and all kinds of things coming soon?
Just a few things, man. I have no idea, but it's gotten busy. So like you said, SharkFest is next week. I'm going to be doing a threat hunting course with Wireshark. I'm real excited about that. And then Defcon, actually, I put in for two different things for Defcon. One is a workshop. It's just a 4-hour TCP workshop. And the other one is a conference course. This is the first time. It's Defcon 30. This is like the big homecoming, right? So they're doing trainings after Defcon, and they're 2-day trainings. So they went ahead and approved the other one I'm going to be doing, which is TCP for hackers. So if anybody's around, come find me.
But I mean, the good news, I think, which we need to announce is you going to be turning those courses into Udemy courses or something similar. Is that right? Absolutely.
I want to take this content and together with you, if I may presume, make that into some cyber. Yeah, definitely. I think that there's a good niche. There's a space for some more threat hunting content with Wireshark specifically. So for sure.
Now looking forward to that. But Chris, in today's video, we are going to be covering UDP Deep Dive. Is that right? We've done a TCP. A lot of people want more content. So today we're going to cover UDP, if I understand right.
Absolutely. I think that's a good topic. I think it's a lot of interest out there. And hey, if you're doing an interview, if you're doing a cybersecurity certification, if you're doing a networking certification, it's just an important thing to understand. And we're going to dive into it.
So, I mean, I'll start with this. UDP seems to be becoming more important. In the past, we used to focus a lot on TCP. But recently in the last, few years, UDP suddenly seems to be becoming more and more important. Is that correct?
Yeah, it's definitely gaining ground. It's gaining, you could say it's taking some of the workload back from TCP, especially recently. Part of the reason there is that an emerging protocol it just got ratified into a standard last year, but the QUIC protocol, we've spoken about that a bit in a previous video, that runs over UDP. So now UDP is basically making a bit of a comeback.
And also, I think you mentioned offline, there's applications like Zoom that we're using at the moment. They use UDP, is that right?
Yeah, they do. So you got Zoom, you got Teams, you have other unified communication platforms that, and it's not just expressly UDP. There's definitely TCP conversations that they still maintain and control traffic and so on. But a lot of that is happening over UDP as well. So you're 100% correct. I know before the needle was definitely toward TCP over the internet and even internal on an enterprise, but you start to see it come back a bit toward UDP. So that's why we need to dig into it.
So Chris, again, we're talking too much. I want to get into a pcap because that's your thing and you really teach us a lot there. Can you do something similar like you've done in the other videos where you show us UDP and Wireshark, explain why UDP is important, look at the details, and I'll keep quiet and let you take it away.
No worries. I think that sounds like a great way to go. I think it's more fun to get the hands on too. So first, you know where I would start is, when we first started talking about doing a deep dive into TCP, I thought, well, David, how can we dive deep into TCP? Or I'm sorry, UDP. When we started talking about a UDP deep dive, I thought, well, it's 8 bytes. The header's 8 bytes. How deep can you go into 8 bytes? But I thought I would illustrate it this way. Now, for the viewers, if you haven't been familiar with RFCs and what those are, requests for comments. So those are basically the standards that define protocols. Okay, that's something you gotta know if you're going into IT, right? All right, so you can see on my screen here that I have a few tabs up, and these are some RFCs. Now, again, requests for comments. These are really important to understand. And for me, a way that I've been digging into protocols throughout my career, I pull up an RFC, I pull up a pcap of it, and that's how I understand how that protocol works. But I thought this was interesting. So if you take a look at RFC 791, okay, this was released in September 1981. This is IP, the Internet Protocol. What I want to draw your attention to is check out how many pages it is. This is a PDF document that is 51 pages. That's how much space of page it took to define IP. Let's kick over to TCP. All right, this is the TCP standard, and it's a RFC 793, TCP, same time, and check us out, 91 pages, right? So IP, 51, TCP, 91. QUIC was released as an RFC. And sorry, I was just digging into it earlier today. So let me come up to the top here. So RFC 9000 is QUIC, and check us out, 151 pages.
Wow.
Woo!
Yep.
It's complex, right? And no lie, QUIC has a lot in there. Check out UDP. It's 3 pages. That's including references. So I'm going to scroll through.
I've got to say this, Chris. People complain about some of the training that, like CCNA or whatever training, and saying, oh, you guys are training the same stuff that you did 10 years ago. But this stuff is still valid, isn't it? Because you're showing us RFCs from the 80s.
100%. Absolutely. Now, there's been some adjustments to those protocols, right? Like TCP, for example. This is September 1981. But there's follow-on RFCs that were extensions, were options, were different. They're called transmission algorithms. So, yeah, it's not the original state that it was back in September 1981, but the core protocol still has a lot of that structure. Point is, though, UDP hasn't changed much in this amount of time. And just before IP and TCP went into standard, here we have RFC 768. This is UDP. It's 3 pages. Here's my point. UDP is simple. It was designed to be. And really, it's not. Right here is the header structure. We literally have a source port. We have a destination port, a length, and a checksum. Boom. That's UDP. Now, on your test or in your interview, they're going to ask, okay, what makes UDP different than TCP? Well, as we've learned in our TCP Deep Dive, TCP is a connection-oriented protocol. It establishes a connection. It's almost like when you pick up the phone and you call somebody and I say, hey, David, how you doing? David says,
Chris.
I'm doing good. Hey, what's going on, David? How you doing today?
Good. 3-way handshake.
Yeah, good. So this is why I'm calling. Right? So that
why are you
setup,
calling? Yep.
Right. That setup had to happen. You know, and in that first, hey, David, I send you a few things just to let you know what I would be doing throughout the course of this connection and seeing if there's options you support and so on. UDP is not like that. Let me flip over to a pcap. It's already been too long since I've been in here. In fact, I've been capturing, we're doing part of our recording on Zoom. So I've been capturing this while we've been having this come up or getting this up and going, just to show you that Zoom predominantly is over UDP. We're going to focus just on the UDP aspect. Let me grab a UDP packet. Now, if you want to grab one off of your network, shouldn't take you long to find one. DNS runs over UDP. DHCP runs over UDP. Any voice traffic typically does. If you go out to the internet and your corporation supports QUIC going out, you're going to notice that QUIC is over UDP. Let's just focus on that aspect of it for a minute. I just clicked a packet. I'm going to not focus on layer 2 or 3. Let's go to layer 4, UDP, and boom, it's just a simple header. Let's see what's there. Source port, it's a 2-byte source port. So we're probably familiar with what some of those ports are. In this case, this is a high number port on this side, high number ephemeral port. Destination port, okay? So I could be talking to a Zoom server out there, and that Zoom server could have told me over a control conversation like, hey, Chris, we're going to establish this call over 8801. So go ahead and hit me back on that port. Length, checksum. Okay, so UDP is connectionless. It's just best effort, send it and hope it gets there.
Yeah.
But if it doesn't, if David doesn't acknowledge in any way, UDP, his job is done. He doesn't have to resend. It's not his job to retransmit. Now, if something does get lost, let's say, for example, DNS. So I just have a simple DNS packet, okay? So here's DNS is actually a DNS response. So let me just come up here. All right. So this is just a DNS request and response, very simple. And this is just something I just grabbed right off my network. I can see UDP is going to port 53, but this packet just comes right out. I don't first establish a connection to the DNS server when I'm doing DNS over UDP. It's possible I could be doing some aspects of DNS over TCP Maybe like a zone transfer or some aspect of DNS can still happen over that because every byte does matter. But in this case, DNS is a simple way to see how, well, I just send and I hope that you catch the ball. If you drop it, UDP's job is done. Now, does that make UDP unreliable?
Yeah, my favorite question, like, what happens if you're doing a Cisco iOS upgrade with TFTP and you lose some of the data? What happens?
That's a good question.
That's always my favorite one. Yep, go on, sorry.
That's a great question. And I like it with DNS too, because, hey, if we don't have DNS, then we're in trouble, right? So why would we take such an important service and run it over an unreliable protocol? And that's because the reliability isn't at the transport layer. It's upstairs. We take the smarts, we take the intelligent part, like, did you actually get it, David part? And we put that up into the application. So what usually happens with DNS is DNS has a timeout. Like, hey, I'm going to send this request down to UDP. You go ahead and wrap it up UDP. You just let it go and off to the other side. If I don't hear back within a certain amount of time, DNS will take responsibility for retransmitting it. So typically with UDP, just as a UDP protocol, the smarts for retransmission, for a topic called flow control, for other mechanisms of making transmission efficient, UDP doesn't have the mechanism there. Instead, it relies on the application to be more intelligent, smarter. The smarts are up in the app, where it's flipped with TCP. You can have smarts up in the application, but TCP, his job, his responsibility is to get this data from me to David, and I got to make sure every single byte got there. TCP cares about every bit, every byte. If something doesn't get over there correctly, my job, TCP, is to retransmit it. UDP doesn't have that mechanism. So since that's true, UDP typically is used when when things like streaming or I want low latency. I want things to be transmitted over to my friend David, and I want him to just process them as quickly as they come in. Like, I don't want to wait for retransmissions. A lot of times voice and video can handle UDP well, because take voice, for example, like voice over IP calls. If you or I are on a call, David, and things get a little spotty and we get hit a little bit of static, it's better for our brains if we just keep on going, right? You might ask me like, so what did you say, Chris? Could you repeat that? But what you wouldn't want is for me to get a sentence out. Let's just say that I said a whole sentence. Packet analysis is very fun. Let's just say that. So what if I lost the word is? Packet analysis, very fun. Is. So if UDP takes responsibility for retransmitting, stuff like that can happen where we're getting real-time traffic out of order, and that can be more confusing. In some services, it's just better if we just lost it and we keep going. Or in a service like DNS, the smarts are upstairs where if something gets lost, it takes responsibility for retransmitting.
The voices and video is such a good example, because if, like with video, it doesn't matter if part of the screen is messed up, you still can follow what's going on, and the frame gets refreshed anyway, doesn't it? And with voice, like you've said, it doesn't help to retransmit. You're going to ask the other person if you can't make out what they were trying to say.
So in this trace, we can see, if I just pull off that DNS filter, if I just slide down here a little bit, you can see a lot of UDP traffic is happening right now. And this is predominantly Zoom. One of the reasons why Zoom would use UDP is because, like, it's real time.
Yeah.
Like me and David want to hear each other in our voices and even our videos. We're okay if the quality is slightly bad for just a little bit and then it improves. We've all seen that. Or even if you're talking to somebody on the other side of a phone call, if you have a very slight bit of loss, it's okay for your ear to piece that together. As humans, we generally can figure out, or our brains kind of fill it in. A service like voice and video can handle a little bit of loss. When loss gets really bad, though, we've all heard that. When you just can't make out the other side, and we've all said, hey, why don't we just start this phone call over? Let's just hang up and try again. That's when things, UDP, it's not going to retransmit, right? So that's when the service will be affected, and we have to either find out why that loss is happening, or take another path, or go down that troubleshooting track. what I thought we would do, just to have a little bit of fun, I thought we'd actually look at a voice over IP call. And I thought I'd show you guys a few tricks of what I do when I'm looking at UDP flows.
That'd be great.
Where my eyes go and how we can troubleshoot. This isn't going to be a VoIP class. I'm going to keep it UDP just to make sure we stick on that theme. Yeah. But since voice use it so much, I thought this might be a good natural next step.
I think the thing is, Chris, you've got so much real world experience, and that's what makes these calls so, these conversations so amazing. Is we've covered some of the theory now, and that's the kind of stuff that you'll learn in a basic CCNA class or something along those lines. But let's get your real world knowledge. How do you track problems down? Because I'm assuming there's a much less information available to you than you have in TCP. So how do you solve problems?
Yeah, that's a good question and a good statement. With UDP, there's something I want everyone to keep in mind. It's a connectionless protocol. That's true, like we just said. But it does something called message boundary. It respects message boundaries. Now, this is why I want everyone to remember that. Is because UDP, when it gets a datagram from an application, that message is just a finite message. That becomes a UDP datagram, user datagram protocol. I just send it, right? I don't go, let me batch a bunch of information together and make the most use out of this packet and try to be efficient. And, like TCP doesn't want to send until there's 1,500 bytes or let's fill this thing. Let's be efficient. UDP does not have that concept. DNS goes, here you go, boom, send this. SIP, RTP, QUIC, all of them go, here you go, UDP, don't think, just send. That's why, if you look on my screen, you can see this length field. That's why you're usually not going to see a full MTU. You're not going to see a full, nice, huge, full packet with UDP-based protocols, unless it's a QUIC that's designed to take better advantage of it. But there's a few other reasons for this length, but that's just something quick that my eye does. I go, okay, this is a UDP-based stream. Here's SIP. These are two phones that are trying to establish a communication. Now, all of this is UDP, this whole pcap. In fact, if I filter, I'm just going to throw a quick TCP. I just filter for TCP and I have nothing. Okay, so this is 100% UDP. So with SIP and other session initiation protocol and other VoIP setup protocols, usually you have a handful of packets at the beginning, and that's just where a call manager is establishing the connection, the phone is ringing. Once both sides have their phone up, okay, now let's establish what we call an RTP stream, real-time protocol. That's basically where the mechanism says, okay, you both know about each other. Go at it. Go have that conversation endpoint to endpoint. Now let's look at this RTP stream. This is where things get interesting. Now up in the SIP information, one thing that's going to be exchanged is the port information, like what port numbers are going to be used. Or Wireshark can see a port like, okay, UDP 8000. I'm just going to go ahead and assume that that's RTP, and it can look at the payloads and it can call it RTP. So this is what I do when I'm troubleshooting UDP stream. So if you just sent this to me and you said, hey, Chris, the call quality is awful. What's going on here? Well, one thing that I do is I remember that often, not always, often, when you're dealing with a streaming type application, you have data going in each direction. Even if you and I are having a voice over IP conversation, and there's silence on one side or the other, a lot of times you still have idle going. It's just sending a silent packet, right? It usually doesn't stop altogether. It's a stream. So one phone or the other, they'll continue to start sending at each other. And what I can do as an analyst is I can start looking at some of the things that are sent. So let's just take this first packet. And here I can see source port, destination port, length, checksum. That's it. That UDP is done. Let's actually take a look at RTP. All right, so there's some stuff in RTP that I can start to go, okay, I can learn a little bit more about this conversation between these two. One is the sequence number. That's what I'll look at. The sequence number, it's interesting that this is a sequence number of 1. Okay, and you'll notice that if I right-click, I'm going to go apply as column. Right now, we're in my VoIP profile. People can see that down here on the lower, people can see that down here on the lower right. So these are columns that are useful when troubleshooting voice over IP. So I come down here to a sequence number, I go apply as column, and now I can see that I see the sequence number for these packets up here. Well, now look at what my eyes can do. Look at this, sequence number 1, 2, 3. And this is just an ACK in the opposite direction for, this looks like, oh, it's the end of the SIP. So 1, 2, 3, 4, 5, 6. You see what my eyes do? Yeah. 7, 8, 9, 10. In fact, if I take and I just want to see stuff from this one source. Let me pop him up there. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. All right. So if I'm a receiver of this stream and there's some spottiness going on, it's a bad call, it doesn't sound very good. One thing that I'll look for in this sequence number is I'll look for gaps. So do I see a jump in numbers? 10, 11, 12, 13, 14, 20. And I'll go, hey, David, what happened between 14 and 20? We jumped here. So that's one thing I'll do when I'm troubleshooting a UDP stream is I'll look for something like this that I can hinge on that will allow me to perceive packet loss. Another thing that I'll do, and now that I have this filter set, is I can see that I have a delta time column. Now this delta time, that's the amount of time between packets. So I can see here with G711, it's uncompressed voice. So what that means, okay, I'm gonna be seeing RTP send basically a 200 byte packet, and it's gonna do it every 20 milliseconds. So basically, I want to see 50 packets per second. Now imagine that I was capturing on the receiver. If I was 196, and this is David, I'm gonna say David is 204 and Chris over here is 196. Okay, so I'm capturing this side. So I can not only perceive jumps in sequence number, that'll tell me about packet loss, but more importantly, what I'll do is I'll come over here to delta time, and I want to see this almost like a clock. I want to see 20, 20, 20, 20. But here I do see some variation. I see 16 milliseconds. See 19, 20, 23, 16, 20, 19. That is what we call jitter. Okay. It's a variation of delta time between packets. That's another thing that I'll look at. So if you're ever troubleshooting a voice call and you have a lot of, if the performance really suffers, jitter and packet loss are two big things that could cause that. So that's another thing I'll do. In fact, I'll even go to delta and I'll sort it. And if I jump down to the bottom, there's going to be some larger delays when I'm setting up the conversation. So some of this is going to be SIP and status and so on. But what I want to do is I kind of get a feel up here for how much jitter we have in this conversation just by looking at one direction of the flow and then saying, okay, whoa, David, hang on a second. At one point we have a full second. We're already into our flow. We had a 1 second delay. Let's go ahead and resort and look at that. Okay, so we're ripping along with this phone call. Okay, rip, whoa, 1 second. And then rip. So if I was the receiver, I go, okay, David, either you paused for a second. I can see my sequence numbers. There's my identification number, but my sequence numbers are sequential. So this one and this one left the station at 20 milliseconds. So now I want to go, okay, where did this guy park for a full second? Why did we park him? That's significant amount of time.
That's massive in a phone call, isn't it?
Oh yeah, that's a lot of jitter buffers. They're meant to wash out around 40 milliseconds, and that's because data's flying in, and I got a human ear on the other side here. So my job is to smooth out all of this jitter and make it nice and smooth for this ear, this human ear. So those buffers can handle about 40 milliseconds. But what happened here is all this came running into that jitter buffer. He played it to the human ear. And then we had this 1 second gap before the next section came streaming in. So what I call this is, I just say someone got stuck at a stoplight. You ever hear this before? Let's just say me, you, David, and 10 of our friends. We're leaving your house and we're going to go to the airport, and we leave at 1 minute intervals. Like all of us have our own car. We got to go catch a flight, literally 1 minute intervals. What are the odds that we're going to drive from Oxford to Heathrow and we're going to arrive in 1 minute intervals?
Very unlikely. Very unlikely, especially in England.
Right, yeah. You probably have a couple that come in and then, there's a gap and then maybe a couple more and then a gap. So that's where when you see those kinds of things in these flows, you can start to go, okay, well, this probably left the station. We left at 1 minute intervals, but when we're arriving, someone got stuck at a stoplight or they got stuck behind the big truck or, whatever the case may be. So those are some tricks that I use. Again, I don't want to deviate too far off the topic of UDP, but these same types of principles are what I look for when I'm troubleshooting UDP flows, even for Teams, for Zoom, try to find out, okay, typically people don't call me and complain if things are too clear and too good. Usually they're calling because, you know, the performance is terrible. So usually that's gaps of time or packet loss. And that's what I look for.
What's interesting, Chris, is you didn't spend much time on UDP. You jumped straight into SIP and RTP. So is it fair to say that you would spend most of your time on the protocol above UDP because that's where all the sequence and all the other information is?
That's fair to say, yeah, because even in a quick example, which I'm going to bring that up in just a moment, the smarts are in the application. So what I have to do is I have to get a feel for how the application is using UDP to troubleshoot it. Let me give you an example of that. I actually caught a Microsoft Teams call when I was getting ready for our chat here. And, ooh, got some QUIC here too. So this is great. So the QUIC was probably from a browser. It wasn't from the actual Teams call. But while we're here, let's take a look at a QUIC packet. Now, I'm going to go from here to QUIC. Let me switch over to my QUIC profile. The reason, because QUIC has some nice colors and stuff that help me to spot things like initial packets. That's the first part of a QUIC conversation. Now, QUIC, we've talked a little bit about QUIC. We won't go deep dive too much into QUIC right now, but if we see QUIC sits on UDP, sits on IP. So QUIC is actually, it's again, emerging protocol. It's taking over a lot of workload on the internet now. There's a lot of sites that are coming on board to use it, but it gets an interesting rap right now. People are like, well, it's over UDP, so it's not reliable. False. What they did is they just created the smarts into QUIC itself. So QUIC handles retransmission. QUIC handles flow control. If there's any loss recovery, even congestion algorithms, like how fast should I send without overwhelming this network? So it's true that the transport layer involves UDP in an application like this, but you could almost say that QUIC almost shares the transport layer with UDP. It's like, yeah, UDP, okay, just here's a datagram, go. I'll handle all the smarts. We couldn't put QUIC directly onto IP. Like imagine if UDP was gone. We couldn't take QUIC and just smunch it right on top and just put it into an IP datagram. The reason, it'd be really hard to adopt it because who in the world has a QUIC port where every device under the sun knows about UDP? So QUIC is really borrowing UDP to just say, okay, just since the world loves you, no one loves me yet, just carry this. And don't do any thinking. I'll handle the thinking, right? So the retransmission, the recovery, those kinds of things, all happens at the QUIC layer. We just happen to be using UDP.
Yeah, this is great. I'll just mention I'll link it below. I interviewed Robin, who helped write QUIC in a separate interview. He was explaining a lot of what Chris has just mentioned and in a lot more depth. So if you really want to get into it, have a look at the video below.
Okay, I got to plug him for a moment. Robin is amazing. That guy, yeah. he literally had a hand in writing this protocol. So definitely go check that one out for sure. Now, let's switch gears. I'm going to go to conversations and I'm going to go to UDP and I'm going to just sort on packets.
This is Teams, yeah? We're just looking at Teams.
We're looking at Teams. We're about to. I see I've got a big conversation up here. So I'm just going to right click it and I'm going to set a filter for that. I could do this another way, but this is just the quick and easy do. Quick, haha. This is just a fast way to do it. And this right here was a call over Teams. Okay. Now, I'd like everybody to just deal with, we're not going to go too far into stun right now. If we just select that, it says session traversal utilities for NAT. That's a whole nother protocol. Yes, uses UDP, basically allows applications like Teams and so on to handle NAT traversal, NAT translation, because sometimes binding can happen and Teams can lose a connection because NAT didn't know to let it go on to the next connection. That's the basic stun conversation. But what I'd like to focus with you on is if I come down here, this is basically where you can see that this is where we start to see our ports. We have a little bit of setup here, but then we just have a UDP packet. And if I scroll, and 900 bytes, that just stuff's kind of flying around. This is often where I find myself when I'm troubleshooting. Like, real talk, everybody. This is like as real as it gets. If someone sends me a Teams pcap and says, Chris, what's wrong? It was bad. This is all I have to go on. It's encrypted, right? If I click on a packet, literally I get UDP and data. So Teams knows within itself how to decode this. It knows how to decrypt it. It knows if something was lost. These smarts are up within the application to decide, do we resend or not? Depending, is this a text message? Is it a call? Is it a video? Is it voice? So all of those determinations are made by the application. For you and me as troubleshooters, the best we can do, if we're not actually on the endpoint and using troubleshooting tools within that app, because Teams does have a few little things that we can look at. If I'm just a protocol analyst on the wire, I come here and basically this is what my eyes have to start to do. I have to start to go, okay, all right, so this is a Teams server and it's sending some data down this way. All right, so I got 32 milliseconds, got a few packets, 34, 33, few packets, 28, 37. I start to notice a bit of a pattern. That starts to look like some type of either burst latency or that could be true network latency, that it's waiting on something. I start to scroll through, and those are the things that my eyes do. I start to look for those patterns. 33, 25, 35. Well, if this looks like a sort of pattern, then it's probably true that if I see a much larger numbers than 25 milliseconds, 33 milliseconds here, that's probably a bad thing. If I saw the 1 second that we saw before and I see a bunch of that, I could go, that's probably where we are seeing some issues. Or if I start to see some other things, let's just say UDP just stops, or what if TCP comes in and sends a reset, or I start to see that type of behavior. But if I just sort on delta, let me jump down to the bottom. If I come down here, so I'm just going to ignore the stun just for now. My eyes are going to look over that because that's usually involved with the setup. My eyes are going to come up here. I'm just looking at the UDP packets. Okay, I got 109, 102, 76, 68. So I do see some areas where I did have some pain along the road. I'm just selecting one of those. I'm going to resort. And this is where I can see, okay, I had stuff come in from the other side. And then my client, so stuff came in from the server. The client waited 102 milliseconds and then it started to transmit. Okay, so there's a little bit of a pause. These are the clues that we have to start to pull off of UDP streams. We don't have a sequence number. We don't have, numbers like that we can hinge on. A lot of times it's just looking at those streams and looking at the timing and seeing, do we see anything that either pauses? Do we see long periods of time between packets that would then cause a reduction in performance?
You know what worries me, Chris? If we're moving to UDP and QUIC and these encrypted protocols, your job sounds like it's going to become a nightmare because you don't have access to the kind of information that you have with TCP.
You just said it.
Yeah. You're not selling this, Chris.
No, it's well, I mean, let's just take this for example. Let me remove the filter I just had. I'm going to do exactly what you just said. QUIC. Let me come down here, conversation filter UDP. This is just one quick conversation, okay? So it looks like I have 2 packets go out from the client. Oh, okay. It had to send 2 packets because it hit a max and it split it up. So I send this out to the server. The server comes back with 49 milliseconds. Now I have an idea of network round trip time-ish. But after that, I'm encrypted and I have little to go on for troubleshooting this kind of protocol. This is one reason why some corporations choose to block it. It just hides everything.
I think Robin was saying that's his biggest concern is corporations are blocking QUIC because firstly, they'll block UDP, often block UDP, and they block QUIC because they can see nothing. So, I mean, in the real world, is that what you're finding? Companies are blocking it so that you can troubleshoot it or that the network people can see what's going on and the security people can see what's going on?
That's a good question. Actually, it's funny. I was just this morning talking to Robin about that exact question because next week at SharkFest, I'm actually doing a UDP session a quick session. And he mentioned 20% of companies seem to be blocking it. It seems to mirror what I've seen. I just see some do, some choose not to. But this is one reason why, right? Because if we look at TCP, at least with QUIC, once I get into QUIC a little bit further down, now this is not decrypted, right? This is just what I would see right off the wire. Literally all I have is IP, UDP, back to our UDP header, and then a QUIC header. Of that QUIC header, I see it's a short header, so it just has a destination connection ID. And then the rest is just blah.
So what are you going to recommend to companies if you're trying to troubleshoot like it's the worst case scenario when you've got this transient voice issue or delay or how do you go about troubleshooting that? Because with TCP you had so many things you could use. What are you recommending companies do? Or just give us your real world experience. How do you go about it?
I'm actually treating these types of services very similar to the way that we've been doing VoIP troubleshooting because it's a very similar type of thing, right? What hurts these services? Loss and delay. That's usually it. So now, what would cause loss or delay? Well, first of all, do I have any kind of prioritization? So now I'm going to go up to the IP header. Do I see diffserv? All right. So do I see any, do I have any code points in here? Do I see some QoS? Now, if I do see the packets with QoS, do I have the routers respecting that QoS? Right. So are things being prioritized? Well, that's with voice, right? So those same, depending on company policy, do they want to do that with Teams as well? And then after that, then I start going after loss. So as far as it depends upon us, from us to our edge, let's do some throughput testing. Let's pull out iPerf. Let's pull out some of these bigger guns and let's find out. Let's do some throughput testing. Let's find out what are the stress points on the network and let's go combing and find interfaces with discards, FCS errors, CRC errors, anything that's buffering. Those are going to be areas where likely I'm getting loss at that point. Multi-point captures. So here I see a packet left David's machine. Here at the edge, I'm capturing there too. Did I see it arrive there? And do I see the induced jitter happening along those multiple capture points? So those are some tools that I use. So let me just replay that for everybody. iPerf. So that's where we can stress test the network to see we're paying for a gig. Are we getting a gig? And then I comb through the network looking for any signs of loss or discards. And then when it comes to jitter, are we using QoS and does the network respect those policies? Many times when I'm troubleshooting systems like VoIP, I can find the problem just going down those three many times. Problem is that a lot of times these are internet-based services, right? So now it's like, okay, QUIC's going off into the big cloud and it's off into a cloud environment that I have no control over and it's talking to, in Teams, it's going off to a Teams environment that the carrier is something I don't control. So that's something we have to consider these days, right? It's not all in-house anymore.
What I find amazing is UDP supposedly is simple, but what you've just shown us is it's actually going to be a lot more complicated moving forward, I think, because, the UDP protocol is simple, but it's all this stuff like QUIC on top of it that's actually making it extremely difficult, especially because it's all encrypted.
Yeah, absolutely. And there's a lot of fear around it, right? So I do think, Robin was mentioning to me this morning, I imagine he did to you too, that, it'll take some adoption time, but, we need to move forward from TCP. TCP is going to be around. I don't think that UDP will completely get rid of TCP. I think that's in a world I probably won't see. TCP is still like in-house applications. There's still applications that heavily use it. It's still a very reliable protocol. It's done a great job for a very long period of time, but we are hitting the boundaries of its capabilities. And to move forward from here, we just have to do things a new way and to keep things secure. And that's why QUIC over UDP is becoming that future.
So tell me, Chris, what must I do to understand or learn this better? UDP, you only spend like literally a few minutes on UDP and then we've jumped into individual protocols. Are there any more captures or have you got advice like of courses I could take or books or what kind of things should I look at learning? Because Because, I mean, I just look at this and I just think QUIC is a whole new world. And then you've got to learn like DNS. I joked about TFTP, but then you got to understand TFTP. But I think QUIC, I think Robin mentioned 25% of the internet is already using QUIC, and that's growing. It seems like QUIC is the protocol to study, yeah?
I think to a point. Right now, what I would do is, ironically, I would learn QUIC better. It's actually good to learn TCP very well. If you take TCP and become just a TCP Jedi, TCP, someone might disagree with me for saying this, but I think this is the way that I've had to learn it. Basically, if you just take a bunch of TCP sessions, like connection-oriented sessions, and put them on top of one UDP payload, that's QUIC. So the better that you understand TCP, the better you're going to understand and be able to transition to a protocol like QUIC. I think something that would be better for people to understand is, or spend their time learning, keep UDP simple, because it is. Keep in mind the things that I just said. Oftentimes, in many cases, not all, but in most cases, something I go after first, packet loss and jitter. Now we're down to the network. What's causing packet loss? So now let's go hunting for low throughput. Let's go hunting for congestion. Let's go hunting for FCS errors, discards. Those are network troubleshooting concepts that are the bedrock for troubleshooting. When we have a problem with a service that is run over UDP, a lot of times we need to start there, look down, make sure that's all healthy, and then we can pass that off to the actual service itself and do further troubleshooting there.
Are you finding that you have to do decryption, like try and get clients to decrypt the stuff so you can actually look into the packets? Because it could be an application problem. If the network looks healthy, what do you do then?
Yeah, that's a great point. It's something that I've actually had to change my tune on. So, all right, let me just show you real quick what I'm talking about. Back to my screen. Like here, for example, here I've got a TCP conversation, a client hello. Look at that, right away, a retransmission. Okay, so I'm able to, let me just filter on this, just see what's going on here. So with TCP gives me so many indicators. And the reason is because TCP has a sequence number. If I come down here, I have a sequence number, an acknowledgement number. This right here is all gone with a protocol like QUIC, right? So I can't rely on, basically, I shouldn't say it's all gone. It's all encrypted. Yeah, I can't see this.
Yeah.
Okay. So it's still there, those concepts. So up until 2014, 2015, I'd work with a lot of my customers and they would send me slow applications, things that weren't optimal, and things weren't working very well. And I was able to resolve those issues without decryption because right here I would see things like this. Oh, SYN-ACK, that's 10 milliseconds. Whoa, 122 milliseconds. That's a lot of time. Just, yeah, why go through the decryption if you're complaining about slowness and I can see that slowness here at the transport layer? Why bother decrypting? But now that's changed. See, now things like not just HTTP 1.1. So in a little bit of an older time, I would see requests and responses go over an encrypted TCP flow, and it would be request, response, request, response. I could even measure application or server response time in an encrypted TCP flow because I knew if I saw a big packet go to the server, I could start a stopwatch and I'd see the big packet come back and I'd stop the stopwatch. There's my application response time.
Yeah, so you couldn't read the details, but you could see what it was based on the size.
Packet size, exactly. Yeah. That was huge. Well, problem, HTTP 2 now multiplexes. So now, David, you send me, if you're the client on the server, you say, hey, Chris, give me that JPEG, that PNG, this JavaScript, this, you send me all these gets. And I start to go to work on them. You send them to me 1, 2, 3, 4, 5. There's the gets. And I start working on get 5 first, then get 2, then 1, then 4. So I have no mechanism in an encrypted stream to figure out application response time. It's all just bidirectional TCP traffic. So since we're in that state, I've had to do, and all the vendors around our industry right now have had to deal with this. All the analysis vendors, all of them, all the big names, is now we can't rely on encrypted streams. Now we have to do decryption to properly measure application response time and measure performance. So the answer to your question is I'm doing more decryption now than I ever have in my career. And I don't see it going anywhere from now. I think it'll continue.
I mean, based on QUIC and the uptake on it and how it's getting pushed, it looks like it's only going to get more so, and especially with the security concerns.
Absolutely, yeah.
We want encryption because we want everything to be more secure, but that makes troubleshooting a nightmare. So what tools are you using, Chris? Are there any tools that you use to decrypt? Do you ask companies to use a proxy to decrypt? How do you go about doing that?
I mean, for me, the quick and dirty, the way that I'll do it, and I have a video on my YouTube channel about how to do it from the client side. Yep. And just yesterday, I was on a Windows 11 box. I had a somewhat recent build of Chrome, and I went out to a server. I was able to store the SSL keys. Maybe we can link that below. It's quick and dirty. I don't have to involve anybody else. We don't have to do any certificate pinning. We don't have to do anything fancy, right? It's a way to grab the keys and just take a quick look. If they do have some type of TLS proxy, or I know some firewall vendors have that capability. Sometimes on the server side, there's even a load balancer, or that if that system is already in place, of course, I'll try to make use of it. I haven't yet had a client where I go, ooh, I need to decrypt this. Put in a TLS proxy because that'll take forever, So we do the best we can, but for me as a consultant, usually since I just parachute in and head out, I try to do it from the client side because it's just simple. And it's a great way for everybody to learn how TLS actually does its thing and capture those client side keys and have some fun decrypting traffic. It's kind of fun to see that decrypt on Wireshark.
The problem I see is in the old days, people used to send you pcaps and say, Chris, here's a pcap. Find what's going on. But if they send you a pcap that's all encrypted, now you've got to ask them you've got to basically get them to give you an unencrypted pcap now. Is that right?
No. And this is why. Many cases, I can go a long way without decryption.
Just right? Based on those pointers that you gave us, like delay, stuff like that, yeah?
Yes. I can go a long way without it in most cases. I was just dealing with a customer last week. So it was an encrypted stream, right? So we had an encrypted, it was actually interesting, a lot of what we're talking about. It was like an application that was using UDP and it was encrypted and we didn't have a lot to go on. And I pumped their pcap into Wireshark and I went, wait a second, you have like a gig of SQL happening at the same time. Between this client and that SQL server. And then that client's talking to some other far off country and doing another interesting looking conversation. I think we have something totally different happening here. And they went, whoa. So once we resolved that, the problem improved. So you see right there, I didn't over blame the application because there was a performance problem. There's other things that can induce that bad performance. Congestion.
We won't get into the details, but something was happening on the network that shouldn't have been happening, and that was affecting the application that they were concerned about.
Yeah, exactly. What I did is, again, maybe another video we could do is I could show you how Wireshark graphs, and I put it into the IO graphs, and I just saw this big spike of utilization right at the time they would complain. So what I did is I focused on that period of time, and I did my statistics on it, and there was just one huge conversation that was SQL. I'm like, why is that client talking directly to the SQL server? And they're like, oh, it's not. Yeah. They went, oh, it is. So you know what I mean? Like, there's other things to look for before we go to decryption, right? If it gets to it and I've exonerated as much as I possibly can, or that if they happen to just be able to decrypt, then we move toward decryption.
That's encouraging because, I mean, when we were having this conversation, I was thinking this is just a nightmare, but it sounds like if you understand what's going on in the network and you capture what's going on, your normal troubleshooting skills can get you a long way.
Yeah, absolutely. And that's why, courses like yours, CCNA, and all the other content around how do networks work and how to troubleshoot them. These are skills that are just as critical now as they ever were. So you asked earlier, do I drop everything and learn quick? No, drop everything and learn how to troubleshoot a network. Standard principles. Get that CCNA. Go toward, CCNP if it interests you. And then those skills, that's all I did. Once you can rule out certain things and you see what's left. I think that's a very important skill, specifically when we're digging around in packets.
Chris, do you have any final words or anything you want us to take away with as a final point before we wrap it up?
I just want to encourage everybody to just keep capturing. Don't get lost in the details. Don't get overwhelmed. Just take it a packet at a time. Try to think logically, get some of the training. It's on David's site, Udemy, right here on the channels. Capture. And I mean, one reason why I can look at these PCAPs and they're not dizzying to me is because I do this a lot, you know, so try to spend what time you can learning about these things. I mean, UDP is it's more important now than it ever was, but keep it simple. It's 8 bytes, but it just has a lot of stuff coming on top of it that has all those smarts and all the retransmission capabilities and so on that TCP used to give us for all applications. So I think that's probably where I would just encourage everybody.
I think for everyone who's watching, put your comments below, stuff that you'd like us to discuss. I know you've been asking for a lot of, you know, more deep dive stuff, and we spent an hour or so on UDP and QUIC and other protocols. Also make sure that you go and subscribe to Chris's YouTube channel. I'll link that below. And Chris, a great place to interact with you is Twitter, is that right?
Yeah, come follow me on Twitter at Packet Pioneer. And it'd be great to meet you. So please reach out.
And Chris, you're still doing live training, is that right? So if someone really wants to get into it, you're still doing is it 3-day courses?
Right now, the Getting Started with Wireshark course is 2 days. It's remote. So we can link that as well. You can, or find it, if you go to wireshark.org, you can find on that page, if you hit learn, you'll find all of my trainings, including the Udemy course and also a live course. So I teach a course where you can actually sit and ask questions. And I even have sometimes people bring PCAPs from their environment, and it's a real issue that they're going through, and we'll tear into it and help them get a little further with troubleshooting it.
I also want to mention you do consulting all the time, so people can also contact you on Twitter or wherever, or your website. Is that right? So Twitter or your website to get consultancy from you.
Yeah, absolutely. Yeah. Yep. Yeah, I do packet analysis, network analysis. I am doing security forensics, some threat hunting now. So absolutely. If you have a packet level question or something you need help with, sometimes I'm able to look at something quickly and help you out right away. And, sometimes I do that on my own time. Just I'm curious about what's going on. And sometimes it turns into a paid engagement, especially if it takes a little bit longer. So,
Chris, as always, I really want to thank you, for sharing with us. You've got years and years of experience, and you make it so simple. So, I want to plug your Udemy course and the new courses that you're creating, but really want to thank you for sharing, so much knowledge on YouTube these days.
Great to be here, David. Thank you so much. This is a lot of fun. And look how far we went with UDP. So, hey.
You said it was going to be like a 5-minute video.
Yeah. Hope everyone had fun.
Thanks, Chris. Bye.